First, according to the temperature setting process shown in the figure, an oxide layer with a thickness of about 300 nanometers is generated on both sides of the cleaned sample. First, pour sulfuric acid and hydrogen peroxide in a ratio of 3:1 into the beaker with wafers and mix them to form a piranha solution. For cleaning for 20 minutes. After cleaning, take the glass pieces and wafers out of the piranha solution and rinse them with flowing water for 3 minutes. Then pour the piranha solution into the waste acid bottle and pour it into the waste acid recovery system after cooling. After the glass pieces and wafers have been cleaned in flowing water, for a long enough time, use an air gun to blow dry the surface. Then stick the four corners of the film mask on the glass and try to make sure the film mask fits flatly on the glass. Place the wafer on the holder of the spin coater. And set the speed of 4000 RPM to spin for 40 seconds. And then drop SGXR601 on the center of the wafer. After the spin coating is completed, place the sample on hot plate at 90 degrees Celsius for 90 seconds. And on hot plate at 110 degrees Celsius for 90 seconds to cure the photoresist on this surface. After the curing is completed, we spin a layer of SGXR601 on the reverse side of the sample, with the same steps and the same parameters. After soft baking at 90 degrees Celsius for 90 seconds, and naturally cool down. Place the sample on the hold of the mask liner. And vacuum the sample before close the lid with the film mask head door on it. Lock the lid. And then use the knob to adjust the position of the sample relative to the mask to align it. And use the vacuum contact and hard vacuum function to ensure that the surface of the sample fits tightly with the surface of the film mask. Then, the exposure process is carried out. After the exposure is completed, release the buttons and take out the sample. The sample is removed and placed in a hot plate at 110 degrees Celsius for curing for 90 seconds. After the sample is naturally cooled, the sample is placed in the S3 solution prepared in advance. And slightly shaken for development. After about 50 seconds, the sample is taken out and washed with dewater. And blown dry. Then, the sample is placed under a microscope to observe the integrity of the pattern. Next, the etching process is carried out. The sample is placed in the BLE solution for about 4 minutes. Then taken out and washed with dewater. Before we do the team etching, first we need to use the acetone to remove the remaining PR, and then use the IPA to remove the remaining acetone, and then rinse by dewater. Finally blow dry with the air gun. Before TMAH etching, fill the box with enough dewater. And then put the prepared sample into BLE for 2 to 3 seconds. To remove the oxide layer caused by exposure to air. Take out the sample from the BLE solution and put it in water. Then assemble the sample into the holder in water and tighten the screws. When the temperature rises to 80 degrees Celsius, place the sample in the TMAH solution and cover it with a lid. Note that the temperature sensor must be placed in the TMAH solution. According to the test sample results, the etching rate of the currently used TMAH solution is about 0.5 microns per minute. Our target etching thickness is 30 microns, so our etching time is 1 hour. After team etching is completed, take out the sample and place it in water. Unscrew the screws. Remove the holder. And rinse the sample in flowing dewater and blow dry. Finally, place the sample in the surface profiler. And measure the actual etching thickness by moving the probe. The final etching thickness of our sample is about 34 microns. After the cleaned sample is placed in the holder, the sample is double-sided oxidized for the second time, according to the temperature setting stage shown in the figure. The sample was placed in a sputter and chrome metal deposition was performed. After 1 hour, the target chrome thickness is 200 nanometers. After metal deposition, a layer of SGXR601 is spin coated on the surface. The photolithography parameters are the same as the previous steps. The detailed parameters are shown in the figure. The sample after soft baking for 90 seconds is mounted on the holder and patterned using a metal pattern mask. First, assemble the sample and mask on the holder. The sample and the pattern in the mask are aligned through the image on the display screen. After the alignment is completed, the sample is fixed and exposed. After the exposure is completed, PEB is performed at 1OC for 90 seconds. After cooling, the sample is placed in S3OMIF for development for 50 seconds. After rinsing with dewater, chrome etching is performed in the baker. After chrome etching, the sample was double-sided spin coated with PR. First, SGXR601 was spin coated on the front side. The spin coating parameters were the same as before. The front photoresist was not exposed and directly cured at 1OC for 180 seconds. Then the front side of the sample was spin coated with the same parameters and patterned using the backside etching mask. After soft baking at 90°C for 90 seconds, after the sample was fixed, the pattern was aligned using the reverse light source in the mask aligner. After the exposure was completed, it was developed for about 50 seconds. After the pattern development was completed, the sample was placed in the bowl solution for 4 minutes to remove all oxide layer. Then, acetone was used to remove all PR, and the sample was rinsed and cleaned with IPA and DI water in turn. Before conduct the TIM etching, the temperature sensor should put into TMAH solution, and then heat the solution to 80. Before the final backside etching, the sample is placed in the BOE solution for 3 to 5 seconds to remove the naturally occurring oxide layer. And then the sample is assembled into a holder in water. And then the holder is transferred to a TIM solution at 80. After the sample is taken out of the TMAH solution, in the medium of etching, the surface profiler is used to measure the etching thickness of about 295 microns. Based on this to calculate, the actual etching rate is about 0.43 microns per minute. The required etching time is recalculated according to the target etching thickness, and then TMAH etching is continued. After the final etching is completed, the sample is taken out and cleaned. The sample is wired and fixed on the jig using epoxy. First, we built a displacement measurement system, as shown in the right figure, based on the principle shown in the left figure. We used a laser vibrometer to measure the displacement of the sample when it was given different air pressures through a syringe pump. The final displacement measurement results are shown in the figure. Then, we built a wireless measurement system based on Arduino and HX711 amplifier, according to the principle shown in the right figure. When a syringe pump was used to provide air pressure to the sample, the output voltage of the air pressure sensor was measured through the wireless measurement system. The results are shown in the figure.